So we chose to put MVHR in the house because of its tremendous ability to deliver fresh air. And we looked at this at the Academy at Airflow and were able to understand what it would deliver in terms of benefits for the house. The idea that a lot of the contaminants would be removed from the air when we're breathing them was really appealing. And then of course we add that added potential to cool the air, as well as of course heat the air, but to cool the air as well as a possibility.
As Airflow's sole preferred partner in the field for design and installation of MVHR systems, we were approached to review this project and provide a design and submit for the installation process. We're seeing a fairly large market shift towards MVHR in new housing as opposed to traditional ventilation methods and traditional aircon. Largely in order to meet potential future energy requirements and government regulations and so on and so forth, but also to give people cleaner, fresher indoor air and better indoor air quality as a result. Air conditioning systems of themselves do not comply with building regs for ventilation. Part F requires fresh air from exterior and it requires extraction of stale air from interior to exterior. Air conditioning recirculates air. It doesn't provide the fresh air, so you cannot use it to satisfy your Part F requirements under building regulations.
In terms of the budget, when we originally planned to build the house, we had a very simple MVHR system factored in and air conditioning to some of the major rooms in the house. And then it came to light, having visited Airflow, that the two things could potentially be combined to give us the cooling. So we were able to save on the budget that we'd allocated to the air conditioning and spend more on a much better MVHR system than the one we'd originally planned to build into the house.
Primary differences between MVHR and traditional air conditioning and separate ventilation systems are essentially in energy efficiency. The MVHR pre-cools the air coming into the building and then it meets the cooling coil that's integrated into the system. And so you need less cooling energy to maintain the air at your demand temperature. From this graph you can see what the external temperature is at 39.7, you can see what the average internal temperature is at 25.4, and you can see we're delivering air at the point where the air is hottest from outside. We're actually delivering air at nearly 9 degrees C. This shows how this system can maintain a pleasant internal temperature irrespective of the heat externally. So some of the benefits of MVHR systems include generally lower noise levels, higher grades of filtration of air, cleaner air in the house, removal of dust that's floating around in the house because effectively you've got extraction working 24/7, and lower energy costs because it keeps your house warm in the winter and cooler in the summer.
Both my boys suffer quite badly with things like hay fever, and we have noticed a real difference in terms of their particularly nighttime breathing, and the way the system has worked in the house has helped enormously. And of course the fact that you're refreshing fresh air into the house all the time is really helpful. Both my husband and I work from home now, so that keeping that working environment with fresh air, keeping you alert and awake is also really helpful.
It's really important that when you're starting the road of designing your dream home, working with your architect, that you tell your architect going into it that you're interested in the concept of MVHR. That will mean that he's able to plan for it. He's able to make space for the ducting, make space for the plant, and for the plant installation and design to be simple and easy.
So when we made our decision to install the type of MVHR that we have, we also got a lot of advice from Airflow about other things that we could do to make the house function better. We were not looking necessarily to build a passive house, but to try and encompass some of those good design features into our own home. So one of the very important things was making sure that the glazing in the house. There's an awful lot of glass in the house that we built, making sure that the glazing reflects the sun and minimises the heat coming into the house, as well as doing really thorough insulation. So we did significantly more than was in our original plan in terms of insulating the house and ensuring that the air tightness was at the best level it could possibly be.
One of the considerations for building design is the mitigation of overheating risk. There's a new section of building regulations called Part O that deals with this, and the architect needs to consider a whole range of factors regarding that. MVHR can be used in order to help with the mitigation of overheating. Increased flow rates at night can help cool the building. In terms of the mitigation of overheating risk, we can learn a lot from the passive house standards and the design guidance they give. Even if you don't want to build a passive house, the use of external overhanging shading, external blinds, tree planting in the right places and the right kind of glass values, all of that can mitigate the thermal gain of the building from solar radiation.
I think when you're making a purchase like MVHR, you really need to trust the company that you're buying from. There is a lot of information out there, some of it quite difficult to take on board as a layperson. So having the right advice and understanding what it is you want to achieve from the system is really important. There are suppliers at lots of different levels, and Airflow are definitely at the absolute epitome end in terms of being able to give you what you want from the system.